Good morning, Nana. Gaurav, Kalyan. So today we'll start the mathematical induction. Chapter number 2, mathematical induction. Some basic formula we have to write first. Formula, Nana. Yesterday I already explained. So once again we have to revise. Natural number set. Natural numbers. It is denoted by capital N. So starting with countable numbers are all natural number set, that is 1 2 3 so on up to infinity. And then second one is whole numbers, so that is starting with 0 1 2 3 so on up to infinity. And then third one is integers, so it is denoted by z. And then here 1 0 1 2 3 so on up to positive, and then negative also, negative numbers also up to infinity so on. So that is the set is set of integers, integer set. This is set of whole numbers, and then natural numbers, that is denoted by capital N. And next one, integers also over. Next, real number means all numbers, which includes positives. All numbers are said to be real numbers. Okay. So all includes positives, integers, all numbers are said to be natural numbers, and whole numbers, integers, all those numbers minus infinity to plus infinity. So this is called as real numbers. Next one, sum of first n natural numbers. Sum of first n natural numbers. Sum of first n natural numbers, that is denoted by sigma n. Sigma n means n into n plus 1 by 2. Sum of the first n natural numbers, that is 1 plus 2 plus 3 plus so on up to n. It is denoted by 1 plus 2 plus 3 plus so on up to n terms. So this is sigma n. Sum means sigma. Sigma means summation of the numbers. So sigma n equal to n into n plus 1 by 2. That is next one, sixth one, sum of squares of first n natural numbers. Sum of squares of n natural numbers, that is denoted by sigma n square, which is equal to n into n plus 1 into 2n plus 1 by 6. So that is sum of the squares of the first n natural numbers. Next one, sum of the cubes of first n natural numbers. Sum of the cubes of the first n natural numbers, it is denoted by sigma n cube, which is equal to n square into n plus 1 whole square divided by 4. So again we write in the form n into n plus 1 by 2, which is equal to whole square. Now this can be expressed as, the total thing it can be expressed as sum of the first n natural numbers, that is sigma n square. So therefore the relation between sigma n cube, which is equal to sigma n whole square, this is the relation for sum of the cubes of the first n natural numbers to sigma n cube, which is equal to sigma n whole cube. So that is sum of the cubes of the first n natural numbers, 1 cube plus 2 cube plus 3 cube plus so on up to n cube, which is equal to sigma n cube, that is n square into n plus 1 whole square by 4, that is n into n plus 1 by 2 whole square, which is equal to sigma n whole square. Okay. Basic formulas first you have to learn. Nana, write down first once again. So that is natural numbers, what are whole numbers, integers, real numbers, all positive and negative, whole thing are said to be real numbers. And then sum of the first n natural numbers denoted by sigma n, and then remaining. So values of, once again you have to write and learn first. First you write, Nana, all these formulas. First, write and learn all these basic formulas. Mathematical induction. First, natural numbers. What are the natural numbers? Next one, whole numbers, integers, real numbers, and sum of the first n natural numbers, and sum of the squares of the first n natural numbers, and sum of the cubes of the first n natural numbers. So this is the basic formulas. Okay. First, you have to write and learn. So set of integers denoted by Z, whole numbers are denoted by W, natural numbers are denoted by capital N, real numbers means denoted by capital R. Sum of the first n natural numbers are 1 plus 2 plus 3 so on up to n sigma n, that is n into n plus 1 by 2. And sum of the squares of the first n natural numbers, 1 square plus 2 square plus so on up to n square, which is meaning that sigma n square, n into n plus 1 into 2n plus 1 by 6. And then next one is sum of the cubes of the first n natural numbers, 1 cube plus 2 cube plus 3 cube plus so on up to n cube equal to n square into n plus 1 whole square divided by 4. So that is n into n plus 1 by 2 whole square we can write as. So which is in the form of in the brackets is sigma n. So sigma n means n into n plus 1 by 2. So which is equal to sigma n cube equal to sigma n whole square. This is the basic formulas. Okay. From this basic formula, next one you have to write as sum of the squares of the even natural numbers. Basic formula, another one. Sum of first n even natural numbers. Sum of even natural numbers. Write it as sum of even natural numbers. Even natural numbers which is in the form even numbers always of the form that is 2n. 2n means even numbers. Put n equal to 1, 2, 4, 6 like that. Total summation means sigma. Sigma of 2n which is equal to, we have learned the formula by taking 2 in outside of the number sigma. Now here write as sigma n which is 2 times of sigma n means n into n plus 1 by 2 which is equal to 2 cancel, then you get n square plus n into n plus 1, n into n plus 1 nothing but n square plus n. So that is n square plus n. This is the formula for sum of the first even natural numbers. Similarly, second one, sum of odd natural numbers. Sum of odd natural numbers. Sum of odd natural numbers that is denoted by odd natural numbers always of the form sigma of 2n minus 1. So now write the formula. So derive the formula for 2 outside sigma n minus sigma 1. So in this sigma n nothing but 2 into n into n plus 1 by 2, and sigma 1 means 1 you have to write as n times. N times means 1 1 1 1 as n times means n time 1 into n that is n. So now here also getting the cancel by 2, n square plus n minus n which is equal to n square. Therefore the sum of the odd natural numbers is equal to n square. This is the basic formulas. So n square, so which is equal to sum of the odd natural numbers that is n square. That is n square. Sum of odd natural numbers always of the form odd numbers means 2n minus 1. So 2 into sigma n minus sigma 1 that is 2 into n plus 1 by 2 minus sigma 1 means 1 as n times means you have to write n. So n square plus n minus n. Okay. So basic formula sum of even natural numbers that is sigma 2n 2 into sigma n, and then sum of the odd natural numbers means you have to write as n square. So this is a just a small proof. Sum of the cubes of the first n natural numbers means sigma n cube that is n square into n plus 1 whole square by 4 which is we can write as n into n plus 1 by 2 whole square which is sigma n whole square. So that is the form is sigma n cube which is equal to sigma n whole square. Sum of the even natural numbers sigma of 2n 2 into sigma n which is equal to n square plus n. Sum of the odd natural number that is nothing but sigma of 2n minus 1 that is sigma 2 can be outside sigma n minus sigma 1 which is equal to n square. These are the basic formulas. More, some are more. How many bits? We learn this is the very basic formulas you have to learn and write Nana. Tomorrow I will see the notes in the formula book. Okay. From this next one is uh, what is the principle of finite mathematical induction. This is the what is the principle of mathematical induction. Principle of mathematical induction. What is the formula? How to find? Induction means same arrangement of the relation between the numbers or whatever the values. Mathematical means numbers only. Induction means the arrangement of numbers in the form of numbers some relation. So the first relation, so that is find out by finite. Finite means we can countable. The process of mathematical induction means given statement B has S of n. Let S of n be the given statement. Some statement mathematically they will give. So let the statement be treated as S of n be the given statement. First you treat as whatever the given statement has given. So let it be, the name is let S of n. And then basic step. First we have to write as basic step. The basic step is the basic step if n equal to 1. So if n equal to means in the place of n we have to substitute s of 1. So for all n belongs to n, first case let s of n be is true, we have to prove. The first case is s of n it is will be true, and then second case, that is hypothesis step. Let it be, we can conclude that basic step or inductive step. Inductive step or hypothesis step. We can hypothesis, just we have to hypothesis. We can just assuming, that is hypothesis. Hypothesis step. That is meaning that S of k, so many numbers are there. Small, first we have to treat as 1, and then some any number k. It is will be true. Suppose it is also true, the final step is, that implies the condition is statement is true for S of 1 and S of k also. Then in the finally we can conclude that implies S of k plus 1 also is true. Then we can say that S of n is true. S of n is true for all small n belongs to capital N. This is the principle of mathematical induction. First, read the given statement. We let it be. We have to treat as S of n. And the basic step is, first we have to prove that put in the n equal to 1 in the place of in the statement. It is will be true. And then next another number, let it be some, we can hypothesis as k. So k will be also true. And then third step is, if it is S of 1 is true and S of let k be true, then next term is k plus 1 also true. This is the final step. That then the statement S of n given the statement is always true for all small n belongs to capital N. So this is the process of mathematical induction. So first treat as given statement be S of n. The basic step is let the value put n equal to, if n equal to 1 in the given statement. Let it be true, the statement will be true, we can write as S of 1 is true. And the second case, inductive step, that is, so let it be some number 1, 2, 3, 4, 5. Let the number, another number is, let it be some k. K means any number. So let it be in the terms of k also true. If it is k is true and 1 is true, then the final step is S of k plus 1 is true. Then the statement is S of n is true for all n belongs to n. So this is the process of finding the mathematical induction principle. In the place of this manner, some exercise problems we have. The first exercise is exercise 2. Exercise 2 questions we have to learn first. The first question is, yesterday we learned, but once again I am saying, Nana, the basic question, first one is given that prove the following by, prove the following by using the mathematical induction. Using the mathematical induction. By using the principle of mathematical induction, you prove the given following statements for all. For all symbol is like that, Nana. Small n belongs to capital N. For all means such that this symbol is for all. Okay. First question. Question number 1. A plus D plus A plus 2D plus so on up to n terms which is equal to n by 2 equals n by 2 into 2a plus n minus 1 into d. So this is the basic formula. So already we know that this is APR GPA. We know that values are, the first term is given that as T1 equal to A, and then second term is given that as A plus D, and then third term is given as A plus 2D. In similarly, the nth term is not given. So that is why we are follow the general relation between the numbers. What is inductive? Inductive means the set of arrangement of the numbers in the formation is, relation is what? So relation is, that is said to be induction. So first term is A, and then second term is A plus B, and third term is A plus 2D, and the fourth term is A plus 3D. And similarly, nth term is what? Nth term is A plus n minus 1 into D. This is called inductive step, that is A plus D, A plus 2D, A plus n minus 1 to D. So the relation in between these are A plus n minus 1 into D. So this is the relation between the numbers A plus D, A plus 2D, A plus 3D. Okay, so first basic step, first assuming this the number B, this total statement B equal to A plus D, A plus 2D, something goes on in terms means the last term is A plus n minus 1 into D. The total summation of the total means sigma, in between plus sigma is there. So sigma of all these terms should be equal to n by 2 into 2a plus n minus 1 into d. So this we have to prove. The statement is true or not, just we have to prove. So first prove solution is, so let assuming the question is, whatever the question is, treat as S of n be the given statement, whatever the question is given, let it be the question, let it be treated as S of n. So S of n be the given statement, and the basic step is case 1. So that is case 1 is if n equal to 1. If n equal to 1 means, if n equal to 1, so the basic step is case 1, let S of n be true. Whether it is true or not, we can check it. Put n equal to 1 in the basic step. So n equal to 1 means put in this nth term. So first write as all these things as to S of n in the model. So S of n is nothing but the equation is A plus D, and then A plus 2D, and then treat as nth term in the place you have to write A plus n minus 1 into D, then equal to n by 2 into 2a plus n minus 1 into D. This is the S of n statement. Okay. Now we have to check it by prove the following. What is the principle of finite mathematical induction means? First assuming that S of 1 be true. So case 1 means let assuming that S of 1 be true. Whether it is wrong or right, we have to check. In this is called in the term. So put in the place of 1, that is equal to A plus 1 minus 1 into D, that is D. 0. So that is put in the form of LHS. Substitute n equal to 1 in this expression. Similarly, RHS n by 2 means you have to write put n equal to 1. So 1 by 2 into 2a plus 1 minus 1 into D. So whether it is A equal to, this is LHS, this is LHS part, this is RHS part. In the terms of n, we have to write as 1 means a plus 1 minus 1 into d is 0, 0 into d is 0, a. In the RHS part, you have to substitute, put n equal to 1 in the expression. Put n equal to 1 in the expression means 1 by 2 into 2a plus 1 minus 1 into d. That is 1 minus 1 obviously 0. 1 by 2 into 2a, then a cancel, then it is equal to a equal to a. Therefore, both are equal. Therefore, the given statement is true. Therefore, we treat as it will be true. Now we have to say that we can say that the given statement is for s of 1 is true. Okay, this is the basic step. First, finite mathematical induction means basic step is put n equal to 1 in the case, n equal to 1 in the statement. Whatever statement is given, first put n equal to 1 in the value. So let s of 1 be true, let it be. So we have to verify. So in the place of n, we have to substitute n equal to 1. So LHS means put in the nth term a plus 1 minus 1 into d. Then it is becomes to a. In the RHS term, you can write as RHS term also 2a plus 1 by 2 into 2a plus 1 minus 1 into d. That is 2a, that is 2 cancel. Both are equal to a equal to a nothing but LHS equal to RHS. Therefore, the given statement is true for n equal to 1. The basic step is over. Next, go to the inductive step. Inductive case 2, that is nothing but hypothesis step. Hypothesis step. That is assuming that for any value, whether it is 2 means it will be also, we will check it nana where a plus d, then put n equal to 2 in the expression. Therefore a plus summation is 2 minus 1, that is a plus d. So a plus the second term will be, you can get. If it is a n equal to 3 means a plus 2d only, a plus 3 minus 1 into d. Here also a plus 3d. Here in the RHS also put n equal to 2 means 2 by 2 1, 2a plus 2 minus 1, that is 2a plus 2d. 2 cancel, a plus 2d. In the same way, let the number be k. So assume that some number, let it be k, it will be true. We have to check if the given statement can be changed into s of k. So the question is goes to a plus d plus a plus 2d plus so on up to, write as in the place of k, that is a plus k minus 1 into d, which is equal to k by 2 into 2a plus k minus 1 into d. K by 2 into 2a plus k minus 1 into d. This is the hypothesis step. Okay. Therefore, s of k, there is no change in the expression. Therefore, s of 1 is 2. Next goes to case 3, that is assuming that if unequal to 2 is correct and k equal to, let the k in the terms of k also true. Therefore, let it be, we have to assume that s of k plus 1 be also true. K is true, 1 is true. The next term is s of k plus 1 also be, you can check it. K plus 1 be also true. So write as in the terms of, the expression can be changed into s of k plus 1, that is k plus d plus k plus 2d. In the terms of same as it is, you can write up to a plus k minus 1 into d. Next term is what you have to identify, Nana. Up to k terms we have written. This is the next term is nothing but k plus 1th term, unknown term, which is equal to k by 2 into 2a plus k minus 1 into d. So here also adding both sides. That is why we can k plus 1th term here we have to write. So assuming that s of k plus 1 also true. That is why up to here these total terms are k terms. Now we have to write here as k plus 1 term. K plus 1 term means we have to write in that is why we have filled the blanks I kept. Okay. So how to find the k plus 1th term in the expression. So that is the rough part. How to find the k plus 1th term, that is put nth term first, whatever the question is given, what is the nth term you have to take. Nth term you have to take. Okay. Nth term in the place of nth term we have, that is nth term is a plus n minus 1 into d. Put n equal to k plus 1, we have to, you want k plus 1, then in the place of n substitute a plus k minus 1 into d. Then the value is becomes to a plus kd. This is called k plus 1th term. In both the cases we have to add on both the terms LHS to RHS. In the both the places you add A plus KD. So then the expression, total expression becomes 2K plus 1 terms. Okay. Now we have to simplify, which is equal to taking the LCM as 2. Next K into 2A plus K minus 1 into D, plus taking LCM means 2 into 2 times of A plus KD. Okay, taking LCM means A plus KD. So taking LCM only to both sides, and then the value is K into 2A plus K minus 1 into D, 2 into A plus KD. Now simplify by 2. Now multiply 2AK plus K into K minus 1 into D plus 2 into A 2A plus 2 times of KD. Now arrange the like terms will be one part, that is this is the like term and this is also like term, and the remaining also two terms are KD, KD is there. KD is treated as common in these terms. So 2A in these terms you can treat as common as this total term, that is K plus 1. And similarly KD is common in this K plus. So K minus 1 plus 2. Remaining terms you have to write Nana. K minus 1 plus 2. In this total terms KD as common. Okay, then go to by 2. So that is in terms of K plus 1. So write as here 2A plus 2A plus, what are the one we have? 2A into 2 in this 2A into K plus 1, 2A into K plus 1 plus KD into K minus 1 plus 2 means again K minus 1 divided by 2, divided by 2. So from this K plus 1 is common in both terms. Again you take common 2A plus KD divided by 2. So from this the problem is conclude that it is in the form of K plus 1. Whether verification also you can take. What is the last step is n by 2 into RHS, you can take 2A plus n minus 1 into D. This is verification whether it is correct or not. Doing the verification, all terms should be in the terms of K plus 1. That is put n equal to K plus 1 in the RHS, then K plus 1 by 2 into 2A plus K plus 1 minus 1 into D. So that is K plus 1 by 2 into 2A plus KD, which is equal to K plus 1 by 2 into T. So the question is verified. Therefore, this is verified that S of K plus 1 is true. This is the process is called by using the whatever the method we have to mention, that is you have to write in the last step. By mathematical induction, It is true for all. For all symbol is like this. Small n belongs to capital N. Belongs to symbol is this. Belongs to this symbol is called belongs to. For all symbol is like this. This is called as for all. The symbol notations, Nana, this is belongs to is in terms of this is in the form belongs to, and this is called for all. So for all symbol, this is the method by using by mathematical induction. The statement is true for all. Small n belongs to capital N. Capital N means natural number set. So we have started with s of 1. Similarly, in the place of n, we started with n 1, 2, 3, 4. We have to check, but let it be k term we have taken, that is 1k, and then goes to k plus 1. This is the process is called mathematical induction. Okay. First step is whatever the step is given, you have to treat as s of n be the given statement. First you have to treat as nth term we don't know, that is why we get by AP relation arithmetic progression, that is a plus n minus 1 into d, and then goes to in the place of nth term we write as a plus n minus 1 into d, and then go to basic step, that is the process of mathematical induction. Let s of n be the true, be true, let it be. The process of basic step is we have to assume that the statement be in 1 in the place of, put n equal to in the place of 1, the statement is true or not, whether you have to check out. In the place of n, write as 1, in the LHS simultaneously RHS. So then you can get both sides by a. Therefore, the given statement is true for all. First n equal to 1, the statement is true. In the same way, the hypothesis step is assume that s of k be true. S of k is a plus d plus a plus 2d still going on. A plus in the place of n you have to write k. So that is why you get the value is a plus k minus 1 into d. That is k by 2 into 2a plus k minus 1 into d. Therefore the statement is true. Next third case is assume that already k term is finished and 1 is also true verified. Then k plus 1 also it will be true. We have to check the statement in the place of write s of k plus 1, that is a plus d a plus 2d till going on up to here. This total terms is up to here k terms. Now this is the k plus 1th term. This is the k plus 1th term. This is k plus 1th term. This is adding both sides. K plus 1th term we can adding the both sides. Then you get the total expression will be up to above is k terms. Now write as the k plus 1 adding by both sides LHS and RHS. The total statement will be converted into k plus 1 terms. Now simplify by k plus 1, then how to get means nth term you have to take a plus n minus 1 into d. Put n equal to k plus 1. Then you get the k plus 1 in the terms of the given statement. A k plus 1 term should be a plus kd. This term should be adding both sides. Then simplify taking the LCM k into 2a plus k minus 1 into d and 2 multiplied here 2 into a plus kd. Then 2ak simplify 2ak plus k into k minus 1 into d plus 2 into a 2a plus 2kd divided by 2. From this first term and third term all alike, then take the 2a as common. And the remaining second and fourth term kd is common, k minus 1 plus 2. This plus 2 we have to write here. K minus 1 plus 2 nothing but k plus 1. That is why I am written as k plus 1. Both terms are again common as k plus 1. K plus 1 into 2a plus kd by 2, which is in the form of k plus 1 or not. With that, check it by like this. So this is the verification in the terms of k plus 1. So k plus 1 in the place of in RHS you have to take in the place of n substitute by k plus 1. In this term and this term is same. Therefore the total expression in the terms of k plus 1. Therefore the given statement is in terms of k plus 1 is true. By using the mathematical induction, it is true for 1 is true and k is true, then k plus 1 also true. Therefore, the mathematical induction it is true for all n belongs to n. The symbol is called belongs to. This is called for all. So this is the mathematical induction process. Now let by using the question number 2 write down first. So the next question is a plus ar square plus ar cube till going on nth term which is equal to a into r power n minus 1 by r minus 1. So this is the basic formulas. This is the series in the form of geometric progression. So geometric progression means whereas arithmetic progression is common difference is same. Here common ratio should be same. T1 is A given, T2 is AR is given, T3 is AR square. Common ratio means T2 by T1 whether are AR by A that is R. T3 by T2 means AR square by AR that is AR. So next AR cube by AR square nothing but R. AR square by AR is R. AR by A is R. In all the expression should be relation is goes to R only common ratio. So this inductive steps are all this goes to up to we can write as n terms. The total summation is goes to the value is A into R power n minus 1 by R minus 1. So this is the question is given. We have to prove the total summation is LHS equal to RHS. By using the mathematical induction, we have to prove the finite mathematical induction principles you have to follow. So first principle is whatever the given condition is given, let the naming should be whatever you have to write. Let S of n be the given statement. Let S of n be the given statement. Therefore, S of n such that a plus ar plus ar square till going on. Nth term means what? T1 is equal to a in the process of first problem. T2 is ar square. T3 is ar cube. T1 is a, Tr is sorry, here ar, here is ar and here is ar square. AR square T4 is AR cube is given. Then we can generalize it that Tn equal to T4 means power is 3, T3 is power is 2, T2 is power is 1, T4, T1 is R power 0 you can write. So similarly one term T4 means power lesser 1. Therefore nth term should be A into R power n minus 1. That is why here write in the place of nth term a into r power n minus 1. That is the inductive common relation. Whatever the relation in between, whatever the numbers in the mathematically terms are given, inductive. What is we can conclude. So relation to assuming the result to nth term. That is generalization. This is called inductive. So that is why we can inductive. The step is a into r power n minus 1. Nth term of a GP also be known by using the formula. How to get means by using this formula only we can get the nth term that is Tn equal to A into R power n minus 1 which is as given as RHS. Total value is given that A into R power n minus 1 by R minus 1. So this can be applied that by using the A into R power n minus 1 by R minus 1. So first case 1. That is basic step. Let assume that S of 1 be true. In the place of 1 you can write as 1. So then you can get the value is S of 1 is true or not, we have to check it. So in the place of 1 you can write 1 means 1 minus 1 that is 0. R power 0 means A only. Then all are in first term. S of 1 means summation in between only first term. Write as A only. Anyway you can get. In the RHS, this is LHS part. In the place of RHS, you can substitute, put n equal to 1, r power 1 minus 1 by r minus 1. Then r minus 1 cancel. Therefore, both the LHS and RHS are equal. Then from this, we can say that S of 1 is true. S of 1, now it is true. Okay, the basic step is S of 1, S of n to be by using the basic step means next case 2, that is inductive step. Hypothesis or inductive step. Assume that S of k be true. So that is in the terms of n you can substitute by k, that is a plus ar square, still going on, a into r power k minus 1 equal to a into r power k minus 1 by r minus 1. Whatever step you have to write, in the place of n you write only by k. Assume that S of k be true, that is hypothesis step. S of k is equal to a plus ar square till going on a into r power k minus 1, that is in the place of n we have to write only by replace by n as to k, a into r power k minus 1 by r minus 1. So that is the basic step. So first whatever the statement is given, first find out nth term. First term is a, second term is a into r power 1, t3 is ar square, t4 is ar cube. Then we can generalize it that tn equal to a into r power n minus 1. So first basic step is S of 1 be true. We have to check it. So that is in the place of 1, in LHS, both LHS and RHS we have to write. LHS is equal to A and then RHS equal to, put n equal to 1 in the RHS, that is r minus 1 get cancel. In the place of n you write r1, that is why r minus 1, a into r minus 1 by r minus 1 cancel out. Therefore LHS equal to RHS, S of 1 is 2. And the basic second step is hypothesis step, that is assume that S of k be true. Then in the place of n we have to write as S of k a plus ar square till going on. In the place of n we write as a into r power k minus 1 by r minus 1. Assuming that S of k be true, thus therefore S of k only write by a plus ar square till going on a into r power n k minus 1. Okay, write all those. Next third step, Nana. Third step you have to write, that is case 3. Case 3 means in the place of first part is basic step also true, we will have to verify it, and k also true. Then let assume that S of k plus 1 be true. S of k plus 1 be true. Therefore, in the times of k plus 1, S of k plus 1 is a plus ar square plus ar cube till going on a plus k minus 1 into d. Now here we write down up to k terms we have finished. Now write as here k plus 1 term, we unknown term, that is why kept as same. A into r power k minus 1 by r minus 1, and then by adding the k plus 1th term we don't know, so that is why I'm keeping the fill in the blank. So in this fill in the blanks we have three tasks. Rough part I'm taking. Put whatever the nth term is, you can write a into r power n minus 1. Put n equal to k plus 1 in the expression a into r power k plus 1 minus 1 k, 1 1 cancel, a into r power k. This is the k plus 1th term. So that is why we can add by both sides by a into r power k. This is also a into r power k. Then the total expression goes to up to here k plus 1 for LHS. Similarly, RHS also up to k plus 1 terms. So then it is goes to total expressions will be s of k plus 1. So a into r power k minus 1 by r minus 1 plus a into r power k, adding. Then simplify. Taking the LCM, that is r minus 1. A into r power k minus 1 plus a into r power k into k minus 1. So which is equal to AR power k minus A. Now bases are equal here. Bases are equal, power should be added. Then it is goes to A into R power k into uh, R power k into k minus 1. R minus 1, this is, sorry. Here R minus 1. Denominator is R is there now. R minus 1. Now bases are equal, power should be added. It is not term means here 1 only we have to think. R power k into R power k plus 1 minus A into R power k is minus AR power k divided by R minus 1. So now cancellation the terms by whatever the terms will be cancelled. AR power by AR power k will be cancelled. Then the remaining terms are first term positive term you can write a into r power k plus 1 minus a divided by r minus 1. From this a into r power k plus 1 minus 1 by r minus 1. Whether it is correct or not by checking the verification. By verification you can write verification whether it is correct or not, taking the RHS. Taking the RHS means whatever we have a into r power n minus 1 by r minus 1. Now put n equal to k plus 1 in the expression, then a into r power k plus 1 minus 1 by r minus 1. So both are same, then the expression is true. Therefore s of k plus 1 is true. S of k plus 1 is true. By mathematical induction, it is true for all n belongs to n. It is true for all small n belongs to capital N. This is the process is called principle of mathematical induction. Then it is proved by the given statement is 100% equal. Therefore, the value is goes to first part is the first part is whatever the statement is given, S of n. S of n nothing but nth term by using the generalized inductive generalization step, that is a into r power n minus 1. So first step is basic step S of 1 be true. In the place of n, substitute both LHS and RHS, both are equal. Therefore, the S of n is true for all, true for given statement. Hypothesis step is assuming that S of k be true, then a plus ar square till going on a into r power k minus 1, that is a into r power k minus 1 by r minus 1. So this is hypothesis step. Then goes to the it is k and 1 is 2, both the cases it is 2. Then assume that s of k plus 1 be true. Therefore s of k plus 1 nothing but already we have up to here k terms. By adding k plus 1 term on both sides, that is how to get means in taking the nth term. Nth term whatever in the nth term is given, nth term we have to take a into r power n minus 1 In the place of n, you can write k plus 1. Then you get this is the k plus 1th term. This is k plus 1th term. You can adding both sides. K plus 1th term adding both sides. Adding both sides, that is up to here k terms. This term should be adding both sides. Then the total expression goes to k plus 1 terms. Now simplify, taking the RHS and taking the LCM. Denominator goes to multiply with the second term. Denominator is same, numerator writing as it is. Now multiply, minus a, here a into bases are equal, power should be added. Then it is r power k plus 1, a into r power k plus 1 minus ar power k by r minus 1. Ar power k get cancelled. Positive terms first you write, negative terms second term. From this a is common, a into r power k plus 1 minus 1 by r minus 1. Whether it is correct or not, by checking is a into r power k plus 1 minus 1 by r minus 1. By verification means taking RHS a into r power n minus 1 by r minus 1, put n equal to k plus 1, then you get a into r power k plus 1 minus 1 by r minus 1. This is the process is known as mathematical induction. Then go to the third question, question number 3. 1 square plus, taking one example, 1 square plus 2 square plus 3 square goes to up to n square, which is equal to n into n plus 1 into 2n plus 1 by 6. This is known as sigma n square. By checking the formula also, by using the mathematically induction, we have to check out. Which is in the place of 1 square plus 2 square plus 3 square till going on n square means all these are said to be, all these are sigma n square, okay? Sigma n square, that is n into n plus 1 by 2, n into n plus 1 into 2n plus 1 by 6. So let whatever the step is given, let assume that as per principle of mathematical induction, let S of n be the given statement. Therefore, S of n such that 1 square plus 2 square plus 3 square till going on up to n square, this is nth term is given. No need to find out the nth term. First term is 1 square, second term is n 2 square, third term is 3 square, fourth term is 4 square. Nth term is what? N square. That's all. Already we have given, there is no conversion for nth term also, we no need to write. So as it is you can write n into n plus 1 into 2n plus 1 by 6. As per basic step, first case 1. Case 1 is nothing but basic step. Basic step is let S of 1 is be true. Whether it is correct or not, you have to check. By using LHS here and then RHS up to RHS. In the terms of n, we can write as 1. 1 means 1 square. In the terms of RHS, you can write RHS substitute, put n equal to 1. 1 into 1 plus 1 into 2 into 1 means 2 plus 1 divided by 6, which is 1 square is nothing but 1. Here 1 into 2 into 3 by 6. 2 means 2, 3 the 6. Therefore 1 equal to 1. Therefore LHS equal to RHS. Now we can say that therefore S of 1 is true for the given statement. In the same way case 2 write down. Okay. Case 2. Case 2. So first case is case 1 and then case 2. That is first case is put n equal to 1 in the expression taking the LHS up to this, and this is taking RHS, both are will be equal. LHS equal to RHS, therefore S of 1 is 2. Then goes to the case 2. That is hypothesis step, assume that S of k be true. Therefore S of k such that a plus a sorry It is not a here 1 square. 1 square plus 2 square plus 3 square till going on. Write as in the place of n you write k square, that is k into k plus 1 into 2k plus 1 divided by 6. So therefore S of k is 2. Next case 3 is nothing but assume that S of k plus 1 be true. That is S of k plus 1, which is meaning that 1 square plus 2 square plus 3 square till going on 3 square till going on k square up to here k terms we have finished. Then write as k square term. I am taking the column, and then it is goes to again k into k plus 1 into 2k plus 1 divided by 6. Then it is write as 2 till going on. So then the value here write down as in the place of k write as k plus 1 whole square. Here also k plus 1 whole square. How you get means rough part you can take whatever the nth term is given, k n square is given. Put n equal to k plus 1. That will becomes to k plus 1 whole square. So that is this is called k plus 1th term. This is adding both sides here. Adding both sides k plus 1th term. K plus 1th term here k plus 1 whole square. So that is why adding both sides by k plus 1 whole square. This total expression, this given statement will be now converted by k plus 1 terms. Now simplify. Taking the LCM as 6. Taking the LCM as 6. Now k into k plus 1 into 2k plus 1 plus 6 times of k plus 1 whole square. It is in the form of a plus b whole square. A square plus b square plus 2ab. Now again k plus 1 simplify k plus 1 whole square, or else uh, k plus 1 whole square. Taking the LCM also we can take, simply we can write k plus 1 whole square, k plus 1 whole square. From this we can take the common by k plus 1. Then you get k plus 1 by 6. Then you get the value is, remaining value is k into 2k plus 1. And then 6 times of k plus 1. Taking the common, then you verify k into k plus 1 into 2k plus 1 plus 6 into k plus 1. 6 into k plus 1. So k into k plus 1 into 2k plus 1 plus 6 times of k plus 1. Okay, k plus 1 we have taken common by 6 common. Then you get here only k plus 1 is 6 times of k plus. Taking LCM now. K plus 1 by 6. Now simplify 2k square plus k plus 6k plus 6. 2k square plus k plus 6k plus 6. That is next page. K plus 1 by 6 into 2k square plus 7k plus 6. 2k square plus 6k plus k means to 7k plus 6. Okay. Now simplify whatever the factors we can get. Factoration. Do the factoration. 2k square plus 6. So 6 2 ja 12. 12 means factorized means 4 3 ja 12. 4 plus 3 7. Then you get here 2k square plus 4k plus 3k plus 6. From these 2k as common, that k plus 2 plus 3 as common, then it is k plus 2. Overall common is k plus 2 into 2k plus 3. This is the value for 2k square plus 7k plus 6. Now substitute here k plus 1 by 6 into k plus 2 into 2k plus 3. So this is the value k plus 1, k plus 2, k plus 3, 2k plus 3 divided by 6. Whether it is correct or not, do the verification. Do the verification. Put in the RHS. In place of n, you can write as n into n plus 1 into 2n plus 1 by 6. Put n equal to k plus 1. N equal to k plus 1 means k plus 1 into k plus 1 plus 1, that is k plus 2 into 2 into k plus 1. 2 into k plus 1 is 2k plus 2 plus 1 is 2k plus 3 divided by 6. So both are equal. Therefore, the given statement is in terms of k plus 1. Therefore, the statement is true. Is true. By mathematical induction, it is true. It is true for all small n belongs to capital N. This is the process is known as mathematical induction. So that is mathematical induction process is what? Put n equal to 1 in the place of LHS and RHS, it is 2. And similarly, assume that S of k be true. That is S of k is 1 square. In the place of n, you can write as k. Third case is assume that S of k plus 1, both sides added by k plus 1th term. Therefore, that is get n square in the place of k plus 1, that is adding by both sides by k plus 1 term. Taking the common term and simplify. Simplify means then you get the value is this last step. Whether it is correct or not, verify with RHS. RHS means put n equal to k plus 1. Then k plus 1 into k plus 2 into 2k plus 3 divided by 6. Both are equal. Therefore, that statement is true. By using the mathematical induction, it is true for all n belongs to n. Therefore, the given statement is true. The last question number 4. That is 1q plus 2q plus 3q plus so on n cube. That is nothing but sigma n cube, which is the formula n square into n plus 1 whole square divided by 4. So this is the formula. In the same way, both sides also we can write at the same way. So first let given statement be S of n. Therefore, S of n such that 1q plus 2q plus 3q till going on n cube, which is equal to n square into n plus 1 whole square by 4. Case 1 is what? Put a basic step, that is assume that let S of 1 be true. S of 1 be true means in the place of 1 you can write as 1. That is 1 cube. 1 cube means 1. In the place of this is LHS. And then is RHS you can take here. That is 1 square into 1 plus 1 whole square by 4. 1 cube is 1. Here 1 plus 1, 2. 2 square means 4. 4 by 4. It is also same. Therefore, LHS equal to RHS. Then you get S of 1 is 2. Similarly, case 2 can write here. Case 2 nothing but case 2 is assume that S of k be true. That is in the place of 1 you can write k. That is S of k, which is equal to 1 cube plus 2 cube plus 3 cube till going on k cube, which is meaning that k square into k plus 1 whole square divided by 4. Therefore, S of k is true. Whatever the step, first substitute in the place of 1, n equal to 1, you can write the NHS equal to RHS. In the same way, in the place of k, write 1 cube plus 2 cube plus 3 cube till going on k cube. K square into k plus 1 whole square by 4. Therefore, S of k is 2. In the next step, k is 3, right? K is 3 nothing but S, assume that S of k plus 1 be true. S of k plus 1 be true. S of k plus 1 is nothing but 1 cube plus 2 cube plus 3 cube till going on. K cube up to k terms are over. Then here k plus 1 adding both sides. That is k square into k plus 1 whole square divided by 4. This is adding both sides. That is k plus 1 whole cube, which is now total expression will be goes to k plus 1. Taking the LCM as 4, then k square into k plus 1 whole square plus 4 into k plus 1 whole cube. From the both terms we have k plus 1 whole square is common divided by 4. Then you get k square plus k plus 1 only k plus 1. K plus 1 whole square taking common means remaining term is k square. And then here k plus 1 4 into remaining k plus 1 whole square 4 means 4 into k plus 1. Therefore, k plus 1 whole square by 4 into simplify k square plus 4k plus 1. Now taking the value for k square by factoration. By factoration means 4. 4 means 4, which is meaning that directly you can take. No need to factorize, that is. That is the a plus b whole square form, that is k plus 2 whole square. Therefore, k plus 1 whole square into k plus 2 whole square divided by 4. Whether it is correct or not, by doing the RHS term substitute in the place of k plus 1 you can write. Therefore, the value becomes to RHS verification, that is nothing but n equal to k plus 1. N equal to k plus 1 nothing but RHS n square into n plus 1 whole square by 4. Then k plus 1 whole square into k plus 1 plus 1 k plus 2 whole square by 4. Both are equal. Therefore, S of k plus 1 is 2. By mathematical induction, it is true for all n belongs to n. So all these questions tomorrow I'll check the notes. Okay, bring the notes tomorrow in the college or online. No need to write class work right here. Tomorrow you can submit. Okay, Nana, bye.